Tell us something about your travels.
I traveled to a number of places. One of the places I really spent a lot of time in was in France during the academic year 66, 67. I spent the whole academic year at Orsay. And actually I gave a graduate course there. And there were very good notes taken at that graduate course by two graduate students. Their names were Bachman and Somen. And I decided to write up those lecture notes in a book. So first I decided that I would just take their French notes, which were very well written, and I would try to translate them back into English, but that turned out to be impossible. You cannot do that because of the way French sentences are constructed. Besides that, I wanted to add a lot of other ideas, and that became my book on singular integrals. So that was one thing that happened. Another thing I think that is noteworthy, at least as far as I'm concerned, during that year that I was there, Carl Deleuze came to visit in the spring of, it was 67. And so we were talking and he mentioned the following thing. He said that Laurent Schwartz, in his work on spectral synthesis, Laurent Schwartz had proved that spectral synthesis does hold, I'm sorry, I don't remember whether it does or does not hold on the sphere in three dimensions. And he said he had done this by proving something about the Fourier transform of a function. If you take a function in LP for some p bigger than 1, and you take its Fourier transform, you can define its restriction to the sphere not as a function but as some distribution on the sphere. And you can do this because the Fourier transform of a radial of the sphere decays at a certain order, and that means. So he said, do you think it's possible that the Fourier transform makes sense as a function? So I thought about this question, and so then I later realized that the right thing was, the way to do it is to think of it, does it make sense as an L2 function, as an a priori inequality? And if it's an L2 function, you can use some tricks in Fourier analysis. And then there was the restriction theorem, at least for some p's. And so when I came back from France, I met this young man, Charlie. So he became my student, and I gave him a series of problems, which he solved right away. So I felt, I really now needed to give him a very good problem, and I had thought about this restriction, and I had some vague idea that this restriction theorem, or the fact that you can make these restrictions, is related to this problem about Bachner-Riesz summability. And I mentioned that I had thought about Bachner-Riesz, but the ultimate about proving things for, well, what I had proved was very partial results, and maybe one could do something close to what is the ultimate thing. So I gave that as a problem to Charlie, and of course he found a beautiful result, which was that insofar as you knew the right restriction theorem, you could get the ultimate results for Bachner-Riesz. So that was something very important that happened when I traveled. Let's see, any other travels that...
China?
China, yeah, well, I gave series of lectures there, met mathematicians, but as far as my own work,
didn't have the same influence.
No, it didn't have that same influence as this year in Paris, which had great influence. Also, yes, I traveled in the year 1970. I traveled to give an address at the International Congress, and since I had to give a plenary talk, I had to think about organizing some ideas, and that was very useful because it forced me to organize some ideas and some points of view. And those were memorable travel times.